at assessing cumulative effects in the Fox Creek area, which is located in west central Alberta. This multidisciplinary project involves about 30 people, including research scientists from the provincial and federal governments and university professors, as well as grad students. Fox Creek was selected because it is one of the most active regions for oil and gas production in Canada, and it has experienced some of the largest induced seismic events in the country related to hydraulic fracturing. As you know, a lot of environmental concerns are related to oil and gas development, including surface water and groundwater contamination, water availability, and forest fragmentation, just to name a few. The initial objective of this project was to study potential impacts of oil and gas activities on shallow aquifers. For those of you who may not be familiar with the term aquifer, an aquifer is simply a bedrock or a granular unit, so a geological unit that can be used for water supply. So last fall, different sectors within NRCan identified the Fox Creek area as a region of interest for developing regional cumulative effects evaluation methods in support of the new impact assessment legislation, so Bill C-69, as you know. Therefore, the project scope is now much larger and includes or will include studies on vegetation, forest, wetlands, landscape evolution, and thus indirectly woodland caribou habitat. I could maybe say before I really begin that since this project started only a little bit more than a year ago, limited results and only preliminary conclusions can be reported here. And the results from the different project components will eventually feed each other and be integrated, but in the next few years. The 700 square kilometers watershed that is the focus of the hydrogeological study is located just southwest of the town of Fox Creek. However, larger areas or slightly different areas could be used for the other project components. The region is mainly forested and unpopulated. It is an industrial area. The regional bedrock aquifer is located in the Paskapoo Formation, which is a non-marine unit that corresponds to a complex succession of interbedded mudstone with sandstone channels. It is known to be highly heterogeneous. This is a picture of the Paskapoo Formation. You can see the sandstone channels here and the mudstone matrix. This formation is the most important groundwater supply in the province and the most important aquifer system in the Canadian Prairies. However, in the Fox Creek area, this formation is mainly used by the oil and gas industry. Aquifers at the surface here in the Paleogene Paskapoo Formation and the unit targeted by the industry, the Devonian Duvernay Formation here, are separated by what we call the intermediate zone. And one of the objectives of this project is to study the intermediate zone integrity to make sure that aquifers are not vulnerable to any deep industrial activities. But I'll come back to that later. A distance of at least 3 kilometers separates these two units in the Fox Creek area. To give you a better or more geological picture, here's the whole sedimentary succession in the Fox Creek area. It is around 4 to 4.5 kilometers thick, and it can be divided in two broad lithostratigraphic assemblages. The first one being the Cambrian Mississippian, so corresponding to older rocks. It is dominated by carbonates and shales, some of which are rich in organic matter, such as the Duvernay Formation. The second one is the Permian Paleocene, so presented to the right, is dominated by clastics and coals. The Paskapoo Formation, where the regional aquifers are located, is at the top of this second assemblages here at the assemblage, sorry. Arrows show units that contain hydrocarbons to a greater or lesser extent. The upper formations from the second younger assemblage correspond to the Paskapoo, Scholar, Battle, and Wapiti formations. These non-marine formations are composed of sandstone, mudstone, and siltstone, except for the Battle formation, which is really a mudstone dominated, so nearly impermeable. These are shown here as they were used in the hydrogeological model that I will present in a few slides. We can also highlight using this slide that surficial sediments in this area are really thin or even absent and mainly composed of coarse-grained sediments. A piezometric map provides groundwater elevation and therefore flow direction. So it is a real important product for any hydrogeological study. This one was obtained using, of course, groundwater levels from shallow water wells, but also using topography as a secondary variable, using kriging with an external drift, as few data of water levels were available, and a strong correlation had been shown between the two variables, of course. The cross-section of the two-dimensional model of the numerical model is shown in red here. To build this two-dimensional numerical hydrogeological model, values of hydraulic conductivity, which represent permeability to water, and porosity, were assigned to each of the four top formations based on existing data, since we haven't been in the field yet. Preliminary results confirm that there are two hydrogeological systems that are separated by a nearly impermeable fine-grained unit, the Battle Formation. This Battle Formation is not always present across the study area, so more scenarios and sensitivity analysis will be carried out in the near future. The composition of organic matter and its thermal maturation were studied this year. Organic matter from the Duvernay Formation is of type 2, so from a marine origin. The figure to the left presents the results of new vitrinate reflectance data and vintage data from the GSC database. The figure to the right presents the Rockyval Tmax data for Duvernay samples compiled from historical GSC databases. Both maturation indicators show an increase of thermal maturation from east to west, which coincides to progressively deeper conditions in that direction. The results indicate a transition from late oil window in the east to condensates and wet gas to the west. A similar analysis was made for other shallower formations containing hydrocarbons, such as the Montney. Gas composition with depth was also studied. The goal of this project component is to help us characterize potential sources of dissolved hydrocarbon in shallow groundwater, if some thermogenic gas is found in groundwater during fieldwork, of course. For those of you who may not be familiar with the different types of gas, there are two types of methane: microbial, that is produced by microorganisms near the surface from new or old organic matter. And there's thermogenic methane that is produced by thermal degradation of old organic matter. Thermogenic methane can come from different depths because geological formations that are now close to the surface may have once been buried at great depths hundreds of millions years ago before erosion. Many graphs and indicators were explored. The graphs here show the isotopic ratios of delta to 13C of ethane and methane below versus depth for a given well. The inverted trend indicates an isotopic rollover due to secondary hydrocarbon cracking in an overpressure zone. Mainly due to this rollover of delta 13C values of ethane and the fact that the delta 13C values of methane are very statistically, I'm sorry, similar for formations extending from the Manville to the Duvernay. This will render more difficult the identification of the source or provenance from a deep-seated unit of any dissolved gas in shallow groundwater if it were to show a thermogenic origin. Now let's talk about the geomechanical study. It aims at a better understanding of the behavior of the intermediate zone to eventually develop a geomechanical model of the entire sedimentary succession to allow us to study the intermediate zone integrity. To study fractures in deep formations that could play a major role with regards to upward fluid migration, seismic data were analyzed, among other things. Faults F1 to F7, shown on this figure using dotted lines, are generally oriented in a north-south direction and correspond to subvertical strike-slip normal faults. Colored circles on this figure represent seismic events above a magnitude of 2.5 on the Richter scale. Faults F3 was found to be very well aligned with epicenters of felt seismic events that may indicate that the induced seismicity was related to a fault reactivation. 2D seismic data show that faults F1 to F7 are present only to the top of the Duvernay Formation or close to, so the faults would not propagate into the intermediate zone, suggesting a good intermediate zone integrity. However, 3D seismic data could eventually reveal lateral movement and show an extent of some of these faults through the Wamabun Formation, which would have resulted from thermal dolomitization. The interpretation of the 3D block should begin soon. Also, petrophysical properties were studied. This figure shows that permeability and porosity from core samples shown by the red dots here in the Duvernay Formation correlate well with estimated profiles based on existing logs from the industry. These data also show that the Duvernay Formation is characterized in its lower half by higher shale content and higher P and S wave velocities, which indicate more brittle rocks. And this is indeed the portion that is targeted by the industry. As well, geomechanical properties estimated from core plugs generally correlate well with estimated profiles obtained from well logs and confirm that the shale is slightly more brittle in the lower portion of the Duvernay Formation, with an increase in values of Young modulus and thus rock strength. The goal of the shallow geomechanical study is to dynamically characterize the shallow units to obtain their geomechanical properties to feed the model. Since no data were available, in situ seismic cone penetration tests, CPTs, and multi-channel analysis of surface wave techniques were carried out last March in the study area. This fieldwork will also allow us to obtain porosity and permeability values, as well as info on stratigraphy that will be very useful for the hydrogeological study. Due to logistical field operation constraints and the COVID-19, only unconsolidated sediments could be acquired during this preliminary field program. Our results are currently being processed and interpreted. Since snow is of course part of the water budget, but especially because snow accumulation, thaw, and other processes are often overlooked or oversimplified in numerical models. Also because its chemistry is rarely known, and finally also because the snow cover is very important for caribous, as they can hurt themselves while looking for food for lichens. A specific study on snow was conducted last winter by people from the University of Alberta, which included the sampling of snow for chemical analysis, as well as the measurement of the snowpack thickness and its density. The analysis and interpretation are ongoing. Nonetheless, preliminary results for the chemical data show that most elements correlate positively, although concentrations, for example, metals found are low. They show that the distance between a sampling site and the closest active gas wells seem to have an impact, indicating high correlation with the element concentrations. As you know, wetlands play critical roles in flow regulation and flow control, groundwater recharge and discharge, and pollutant filtration. Due to their importance, the Northern Alberta Institute of Technology carried out a literature review on their current status and sensitivity to disturbances in the Fox Creek area. Within the 700 square kilometers study area, wetlands cover about 17%, with fens and swamps being the most abundant. Woodland caribou, a designated species at risk, primarily eats lichens in peatlands in fall and winter. The creation of linear features such as seismic lines, access roads, and pipelines that affects wetlands and forests also affects caribous, as these features enable greater predation of caribous since they represent preferential travel corridors for predators. Also for this reason, forest disturbance and fragmentation will also be studied by research scientists at the Canadian Forestry Service, CFS, within the framework of this project. While how landscape has evolved over time, among other things, will be studied by research scientists at the Canadian Centre for Mapping and Earth Observation, better known as CCMEO. I'll come back to that in a moment. Okay, how to better assess cumulative effects? That is a big question. An MSc thesis focusing specifically on the subject was initiated last January at Université Laval. The ultimate goal of this research project is to develop a strategy and propose practical and effective solutions to help project proponents and consultants better assess cumulative effects related to industrial activities, mainly to oil and gas, due to the location of the project, on the environment within environmental assessments. That is, of course, very ambitious, but I think it is important to rethink the whole process, but not alone, of course, but as part of a group, notably at NRCan, but also within the entire federal government. This study will be based on first an in-depth literature review to synthesize what has been done so far worldwide on the assessment of cumulative effects. Second, on First Nations experience and knowledge of their territory, among other things, to identify their main valued components and to have their views, opinions, and perspectives on cumulative effects through, hopefully, participatory mapping. I said hopefully because meetings with First Nation communities had been organized at the end of March, but had to be canceled at the last minute because of the COVID-19 situation. Finally, this study will be based on the experience and knowledge of consultants conducting these environmental assessments through semi-directed interviews to have a better understanding of what are the obstacles they encounter during their assessments, among other things. This summer, we will drill 4 or 5 shallow wells to be able to sample rock and obtain porosity and permeability values from core samples. I wanted the well to be cored to have core samples for different types of analyses, but drilling is extremely costly in Alberta, so I am not sure we will be able to afford that. So we might have to settle for conventional water wells, unfortunately. Borehole geophysical logging will probably have to be done at the same time than drilling, as rock of the Paskapoo Formation is very friable, and the wells will very likely need to be cased all along. Due to fieldwork constraints this year, we will hire a consultant from Alberta to supervise the drilling work and hire a local company to do the borehole geophysical logging. We usually do that ourselves, so this time less money will be left for the drilling work. However, having less wells is better than having no wells at all. Groundwater sampling may only take place next year due to fieldwork and budget constraints. Some of the activities that will take place this fiscal year include the interpretation of borehole geophysical logging data from the new monitoring wells, and analysis of hydrocarbon in rocks from new wells if we are able to find coal. The interpretation of 3D seismic data, deep seismic data from the industry, the development of a coupled surface water groundwater model, the development of a preliminary hydrogeological model, so integrating atmospheric processes, and a baseline groundwater geochemical study if we are able to sample groundwater. As mentioned earlier, to cover other environmental impacts, we'll get help from CCMEO and CFS. Activities will likely include on the CCMEO side, the evaluation of potential ecological stress and the assessment of landscape changes over time using satellite imagery, and a spectral characterization of shallow freshwater bodies, such as wetlands, using SAR datasets, to look at the water extent of these shallow water bodies so as to provide means to monitor for changes to these environments. On the CFS side, there will be mapping of potential impacts and resulting changes on ecosystem services at the landscape scale, and a study of functional and structural recovery of forests, since, as mentioned previously, the forest has been significantly fragmented due to oil and gas activities. Thank you very much.